Welcome to this tutorial where I'm going to show you how to run an independent samples t-test in SPSS. Let's assume you have two variables. One variable is your variable of interest, your test variable. So this is here customer satisfaction. And it was measured from a scale from 1 to 10 to indicate the satisfaction level. You can treat this scale as continuous. Then you will have another variable, which is your grouping variable. This variable simply differentiates the two groups or the two samples. So to say, so here we have customer satisfaction levels from two different branches. One is in district A, coded as 0, and the other is in district B, coded as 1. Now we would like to know if there are any differences in the customer satisfaction levels between those two branches. Maybe if there are any differences, you might discover best practices and you want to implement those in the lower performing branch. Now, to run the test, click Analyze, Compare Means, Independent Samples t-test. Your test variable is customer satisfaction. Your grouping variable is the branch. Now you have to define the groups. Here you just have to tell SPSS the codings of the two groups. 0 was district A and 1 was district B. Now you click OK to run the test. In the first table you have some descriptives. Here the mean and standard deviation are probably of the highest interest. You can already see that the branch in district A has a lower mean satisfaction level than district B. Now there's the actual test, the independent samples t-test. What you have here, the Levene's test for the quality of variances, is actually an assumption of the test. Let's look at the F value. So Levene's test is an F test, and next to it you already have the significance value. So the p-value is above 0.05. This means the Levene's test is not significant. This means that the variances are equal. You can read your results from this row. But if this test, the Levene's test, would be significant, then you would have to read your results from this row. Equal variances not assumed. Now, we have the t-value here, it's negative, and the degrees of freedom, and the p-value. Well, this is negative, obviously, because district B was deducted from district A. So that's why there is a negative t-value. And the p-value, as you can see here, is below 0.05 and also below 0.01. So it's actually highly significant. So there is a highly significant difference in means of customer satisfaction across those two branches. So district B, the branch in district B, is performing significantly better than the one in district A. If you want to know more about how the t-value is calculated or the degrees of freedom, etc., I've made another tutorial on this. I hope this tutorial was helpful to you, and good luck in your statistical endeavors.